Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing engineering typology subject. So the subject code is AMEC 24. So today we will learn the basic concept of the friction. So already we have discussed about tribology subject. Is a subject involves friction, lubrication, and wear. These three main parameters are important in whenever two components are in relative motion. So the first one is friction. So what do you mean by friction, and what is the importance of friction, and the types of frictions? What is the theory behind the friction? We will see in this PPT. So the friction definition is, it is the resistance to motion during sliding or rolling that is experienced when one solid body moves tangentially over another. So whenever one body moves on another body, so the body is moving nothing but there is a some friction between these two surfaces. So whenever the body is subjected to tensile load, so there is the opposite force will act on that body. So that opposite force is nothing but the resistance to the motion. So that is nothing but frictional resistance force. So the occurrence of friction is a part of everyday life. While walking, while moving, and while dancing, everywhere in our life, friction is involved. So without friction, we can't walk. We can't drive a car on a road. We can't dancing. So that's why the friction is a very, very important property between two surfaces. Whenever these two are in relative motion, there is a friction. So on the other hand, the most of the running machines, take mechanical machines, the mechanical machinery elements, and the friction is undesirable. So there is a energy loss. What will happen? So due to this energy loss, it leads to wear of main parts. So deteriorating performance due to the heat generation. So whenever the two bodies are in relative motion, contact each other, there is a energy loss. So after some time, it leads to wear. How it will wear? So due to the heat generation. So I will show you diagram. So that is using low friction materials, lubricating surfaces with oil or greases, and changing design so that sliding can be reduced. So all these attempts leads to wear. So these so that's why some sorts of attempts have been made to reduce it. See in this diagram shown the mechanical element, the machine element. So there is a heat generation due to friction. So in this diagram shown, so when machining or any other mechanical operation performing, so immediately the friction will be occur in between the surfaces. So due to this friction, heat will generate. Due to this weight, some wear loss will be occurred. So the heat generated is mainly caused due to the friction only. So that's why there is a energy loss. So next this in this friction, we will use coefficient of friction. So this is a constant value. It is represented with mu. In addition to the value of mu is accounted much lesser than 1. The mu is less than 1 only. 0 to 1. So in practice, mu greater than 1 as shown in table. So it has been observed. Generally, the coefficient of friction depend on parameters, that is such as temperature, the surface roughness and hardness, and this coefficient of friction based on mechanical properties, based on the surface chemical properties, based on the structure, the structure of the material. So here in this table, the coefficient of friction for various metals sliding on themselves shown. See different materials. Aluminium 1.5 and copper 1.5 and gold is 2.5 and iron 1.2 and platinum 3. Very high the coefficient of friction and silver 1.2. So like this shown the different materials coefficient of friction. So this table, this figure indicates under dry lubricant conditions, the mu ranges between 0.1 to 1. For most of the materials, this value, the range of the mu is 0.1 to 1. So very thin lubrication reduces coefficient by 10 times. The coefficient of friction will reduce very thin lubrication. In lubrication theory, thin lubrication and thick lubrication is there. Thin lubrication film and thick lubrication film. So we will discuss later. So this thin lubrication reduces the coefficient of friction by 10 times. See in this figure shows different materials mu ranges under dry lubricant conditions. There is no wet lubrication. So nickel on nickel, gold on gold, and platinum on platinum, and copper on copper. So two materials are here same. So one surface is copper, another surface is copper. One surface is indium, another also indium. So like this, here show the steel on. See, this is another one, steel on tin, and steel on steel, steel on lead, steel on aluminum. For these materials, the coefficient of friction is 0.1. The steel on bronze. So like this structure here shown the values of mu. So in this figure, the shown adhesive friction among various materials. So this due to the adhesion property, the friction increases. While selecting materials, the low adhesion metal pairs must be selected to reduce friction force. So what are the low adhesion metals? You have to identify. The similar material pair must be avoided as similar materials have higher tendency of adhesion. So that's why the similar materials pair must be avoided. They are having a higher tendency of adhesion. See in this figure shown the low adhesion to high adhesion. So here see the first one, indium, tungsten, high adhesion. So molybdenum, chromium, cobalt. See for example here lead with chromium, lead and chromium having low adhesion. different materials, lead and chromium, not similar material. You take similar materials here, lead and lead, lead and tin. See in this diagram, the zinc. So high addition property, aluminum, zinc and aluminum, and then gold. So it is full black. So ellipse is so slow addition, and then half when compared to the previous one, lesser value, and then completely empty. That is high addition property materials. So generally the constant surface, that is static surface, stationary, and one surface is dynamic, that is you can say moving element. One is moving surface, another one is constant, static. So this is certainly the case with mechanical members such as indexing slides and bearings. In bearings, the bearing body is stationary. The inside, the general material is moving element. So whenever the machine element is in moving condition, that is said to be dynamic condition. Whenever at rest position, that is called as static position. Static. So that is stationary position. So regarding friction, very interesting observations stated as follows. So those one is, it is essentially an electrostatic force between two surfaces. Whenever two surfaces are in relative motion, there is essential electrostatic force is required. And one more thing, the friction force is never initiate the motion. It only responds to motion only. It responds to motion. Suppose one surface is there here, so another one block. So you are applying a load in this direction. So whenever it is in motion, then only the friction force will act. Clear? So it depends on the materials in contact with each other. That is based on the material, the surfaces are in contact. The coefficient of friction mu is a critical property of the material selected. Already we have seen in the previous slides. Coefficient of friction, and it opposes the direction of motion. So here the frictional resistance was calculated by using this formula. F is equal to mu r or mu n. So mu is the coefficient of friction and r is the normal force. So here three types of frictions are there, and one is static friction, kinetic friction, and rolling friction. The mainly three. Another fluid friction also there. So I will discuss on next coming up slides. So when compared to the kinetic friction, the static friction is higher value. When compared to rolling friction, the kinetic friction has a higher value. For the same combination of surfaces. So that the static friction is greater than kinetic friction, and then kinetic friction is greater than rolling friction. So when it is the body, suppose if the solid body is in rest condition, so there is a static friction. So there is a lot of friction. Whenever it is in motion, then the slightly reduce the friction. That is kinetic. Instead of sliding, you have used rolling, then reduce friction force. When two surfaces are slipping across each other in the presence of kinetic friction, the heat is generated, more heat is generated, and mechanical energy is not conserved. So here, in another case, suppose the two surfaces are in presence of rolling friction, the less heat is generated. There is no mechanical energy is conserved. So when a ball rolls, so here clearly given in this ball roll static friction without slipping across a surface. So there is a mechanical energy is conserved and no heat is generated. See in this diagram given two surfaces is two-dimensional diagram. One is surface number 1, another one is surface number 2. So in this figure you can see how the force is acting and what is the coefficient of friction, what is the contact between these two surfaces. It shows the significance of force, weight and the coefficient of friction. So here whenever the surface number 2 presses over the surface number 1, there will be friction. Frictional resistance force will act. This sliding force is perpendicular to this. So the normal force is perpendicular to the sliding force. In between these two surfaces, there is a friction. That is, by using mu, you can calculate frictional resistance force. See, whenever it is in a sliding position, see the surface number 1 is the sliding, the tension force is acting, and then surface number 2, the load is acting on over the surface number 2. The opposite force will act. So that is called as the frictional resistance force. For our observation, we can state the following 3 definitions. If the two contacting surfaces do not slide, then the T is less than mu W. So what do you mean by T here? The frictional resistance force is less than mu W. So this is reaction, normal reaction force W and mu is the coefficient of friction. The two surfaces are start to slip. That is F is equal to mu W. When two surfaces are sliding, then the T is plus or minus mu W. It may be positive, it may be negative. So it means whenever it is in a static condition, the mu is less than, the frictional resistance force is less than mu W. When it is kinetic, equal to mu W. When it is rolling or sliding, plus or minus mu W. Whereas in 3-dimensional methodology, the tangential force having 2 components. So to better describe this mathematically introduce in terms of power, E to the E1, E2 and E3. And with E1 and E2 being in the plane of the contact, E3 being normal to the plane of contact. See, here in 3-dimensional, the surface number 1 and surface number 2. So here, X direction, Y direction and Z direction, 3 components are there. So in this diagram shown that frictional resistance force and normal reaction force W in 3-dimensional math model. T1, T2 and W opposite force. From this three-dimensional diagram, you can say if the two contacting surfaces do not slide, then the frictional resistance force power 2 T1 square plus T2 square is less than mu W. So like this, then it is said to be two surfaces are not in a sliding position. So do not slide. In two-dimensional case, the frictional resistance force T less than mu W. But in three-dimensional, so by using this relation, you can state the surfaces do not slide. Similarly, the two surfaces will not start to slip. Suppose this condition satisfied, then it is said to be two surfaces will not start. The surfaces sliding, two surfaces sliding. So then, if the condition satisfied, you can say the two surfaces are in sliding position. So where T of 1 by 2 denotes the tangential force exerted by body 1 on body 2, and V12 is the relative velocity. So how do you calculate the relative velocity? By using this relation, V12 is equal to V1 minus V2. So this is the relative velocity of a body, one with respect to the other body. So it means one with respect to body 2 at the point of contact. V12, the relative velocity of V1 body with respect to 2. The relative velocity can be calculated from the velocities V1 and V2 of the two contacting solids by using this equation. So here in third condition, here given T 1 by 2 is equal to mu W into V12 by V1. So this is modulus 12 and V1. So here the relative velocity of the first body with respect to the second body. Then it is said to be relative velocity. Two bodies are in a relative. The two bodies having relative velocity. For calculation, you can use this equation. Next topic is the types of friction. So here, next topic is types of friction. One is static friction, sliding, and rolling friction, and fluid friction. So the detailed definition we will learn. So first of all, static friction and kinetic friction and rolling and friction we will see one by one. So before going to discuss about these types of frictions, you should know the static and kinetic frictions. So already you know static friction means when the two surfaces are not in a moving condition. And also having highest friction value, so that the surfaces are not moving relative to one another. Whereas in kinetic, one in motion, and then the result, what will happen? The final result, lower frictional resistance having. to keep something sliding than to start it. Similarly, rolling and friction. So reduces sliding friction involved greatly application involved in a very high. So the application is bearings, small cylinders or balls that surfaces roll over wheels. These are the rolling and friction. So that's why before starting friction mechanisms, it is necessary to define the static and kinetic friction. So let us consider a block on the surface getting pushed by a tangential force as shown in figure. In this figure, shown the difference between the static and kinetic frictions. So it may initiate a stick slip also. So here a block having 100 newtons weight, the applied force is acting in this direction. So what is the relation between frictional force and applied force? See, on application of 20 newtons load, the block does not move. So it means it is said to be in static condition on application of 20 loads here. See, this second point on the graph shows that on application of 40 newtons, still block does not move. Application of 40 newtons. So there is a static force equilibrium between application force and a frictional force. On application of 15 newtons load, the block just starts sliding. So at this point of load application, the frictional force remains equal to 50 newtons. See, in this diagram, the frictional force mu down 0.5. The weight of the block is 100 into 0.5. So here 50 newtons. That is the frictional force. So that at the first point there is no sliding, the block does not move. The second point, the application of 40 newtons, still block does not move. And the application of 50 newtons load just starts sliding. So at this point, the load application frictional force remains equal to 50 newtons, but friction resistance decreases subsequently to 40 newtons. So this is called as the stick slip phenomenon. So it is stability, it initiates the friction instability. The friction resistance decreases, subsequently 40 newtons. Next, static friction. In this diagram shows the static friction mechanism. Whenever the horizontal force is applied to a body with an intention to move it to the right side. See, in the first condition, there is no friction between the block and the table. So here why? Because there is no force. You are not applying any force on this block. If the force is applied, that force also very too small, the static friction is greater and the block will not. Suppose very small force you are applying, the frictional resistance force is higher than this applied load. So in that case also there is no sliding. So there is static friction. If a small force shown in blue here is exerted on a block, does not move because the force of static friction shown in static friction is shown in an orange color, they exactly balances the force applied. So whatever you applied force, that will be balanced. So remains in rest position only the block. In third case, see, when the force exerted on the block is greater than the force of static friction, so that the block starts to moving. Once the block starts to moving, all the static friction is gone. But work must be done against sliding friction, shown in green color. So, as long as the body is at rest, the frictional force is equal to the applied forces and then directs to the left side, opposite direction of motion. The frictional force is equal to the applied force and then direct to the left side, opposite direction of the motion, resisting the motion. So the friction is static and there is no motion. But in this case, the force is applied to a body, then intends to move it to the right side. Your applied force, your intention is to move right side. But in this, the applied force and directs to the left side, opposite direction of motion. So that is nothing but frictional resistance force. So the friction is static and there is no motion. So there is no sliding. Next, this diagram shows the force and friction. So, already you know, the more mass, greater mass creates more friction. You are applied to a very high load, so there is the more friction. You are applied low load, less friction. So it is nothing but a greater push is needed to overcome the greater mass. So that is which has greater friction. That is static friction. See in this diagram, two surfaces are there. There is a more friction between the more mass of block, having more force needed to overcome friction. The harder force is needed to overcome friction to move the more massive book. So, when compared to this one, this book having more number of pages and a greater mass, it creates more friction. So, here in this diagram, that turning the more massive book on its edge does not change the amount of friction. So, it's nothing but if you turn the book like this, the force of friction and the force needed to overcome the friction is same. There is no change in force needed to overcome the friction. So that is depends upon the applied, depends upon the body mass. So that's why greater mass creates more friction. Suppose if applied force is increased, the frictional force will also increase until it reaches the limiting frictional force. As the applied force increases further, the body will begin to move. So the limiting frictional force is independent of the applied force but depends on the nature of the surfaces and the normal contact force. So in this figure, so I explained the relation between the force and friction when it is in static and sliding. So it is a very small force shown in blue color is exerted on the block. So the block does not move because the force of static friction and then as shown in orange color is exactly balance the force. Similarly, here a force applied on sliding friction when the force exerted on the block is greater than the force of static friction, shown in green color. So in this case, the block starts to moving. Now, how to calculate the net force? What are the applied forces and how to calculate? The net force is nothing but the combining all forces exerted on an object. So the net force is the algebraic sum of the all forces, whatever forces acting on that body. The total gives the net force. Here, shown some examples. Here applied force is 5 newtons, 10 newtons. So net force is 15 newtons. Why? Because here the two forces are applying in same direction only. 5 plus 10. But in this case, the 10 newtons are applied in this direction, in opposite direction 5 newtons. So this 5 newtons is on the opposite direction. So what is the net force? So that is 10 minus 5. Similarly, in this case, the equal forces are acting 5 and 5. So what is the net force? There is no net force. Why? Because this force is balanced with the 5 newtons force. So in the previous slides already we have discussed this condition. That is 0. 5 minus 5. So it means it is in static condition. There is no motion between the surfaces. The forces in the same direction add forces together. Forces in the opposite direction subtract smaller force from the larger force. So already we have done 10 minus 5. Next, static friction, another example. This figure shows that the object begins to move if the applied force is larger than the lifting friction. So before that, the frictional force increased with the applied force. Here, lifting friction and exerted force, the external force is applied like this, and the frictional force acting in opposite direction. So there is no movement. Once the body starts to move, the frictional force would fall to a smaller value when compared to the static frictional force. So this frictional force remains constant even though the applied force is increased further. The frictional force remains constant if you are suppose you keep on increasing the applied force. Next one is rolling friction. So the friction between the wheels and the ground is an example of rolling friction. Here shown in this diagram, the friction between the wheel and the ground is very less friction when compared to the static friction. Static friction, suppose ground is like this and your body, the blockage, object placed like this. So there is a high friction between these two. Instead of this surface, you have used in between rollers. So the force of rolling friction is less than the force of sliding friction. So in this, very easy to push the object when compared to the sliding. See in this diagram another example figure. Here moving a heavy piece of furniture Suppose you are in our room, one furniture is there, that is you want to move from one place to another place. Suppose uh, the bottom of the furnace and in between the ground there is no rollers or any rubber bushes. While it is moving, very difficult to transfer one place to another place, because the force of sliding friction is very high in this case. Same furniture you are using here, the furniture you are keeping rollers or wheels, heavy furniture, if you are suppose put it on your rollers, the force of rolling friction is very small and easier to transfer one place to another place. You can move, you can place this furniture to another place. So here the more effort is required and more friction also will be generated. Here less effort is required and when compared to the previous one, here less friction will be occurred in between these two surfaces. So this is the difference between the static friction and rolling friction. Next, one more friction is there, that is fluid friction. So already you know, fluids means including water, gases, and then milk and air also one type of fluid. So the fluid friction opposes the motion of objects traveling through a fluid. Suppose airplane here, airplane traveling through a fluid. Which type of fluid here? Fluid is air. So the friction opposes the motion of the object, this the fluid. So that is said to be fluid friction. So suppose a ship traveling through a water. Okay, so these are the types of the frictions I have discussed. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.